So the William W. Hay Railroad Seminar Series is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, we greatly thank the U.S. Department of Transportation for their support. It's appreciated by those of us here on campus as well as those participating via the internet. I'd also like to welcome those of you attending via the internet today. We have representatives from MIT, Amtrak, HDR Engineering, Hanson Professional Services, Metra, Sistra, University of Tennessee, Patrick Engineering, WMATA, Federal Railroad Administration, H.W. Lochner, Parsons, Train Dynamics, LTK, Benesh, HNTB, Patriot Rail, Genesee and Wyoming, Michigan State University, Michigan Tech University, Parsons, Kansas City Southern, RJM Engineering, ARUP, Illinois Department of Transportation, WSP, Chicago Transit Authority, and AECOM. So we've got a big crowd for you today on via the internet, and we really appreciate you speaking today. So over the past half century, high-speed rail has emerged worldwide as a transformative transportation system that has proven to be a safe, comfortable, efficient, reliable, and environmentally friendly transportation tool. However, a number of emerging 21st century technologies are bringing changes that will alter the many aspects of passenger transport, with consequent impacts on the role of high-speed rail. Our speaker today will consider some of these potential impacts and the future development of next-generation high-speed. Tsung-Chung Gao, or TC, has a worldwide reputation as an expert in high-speed rail planning, engineering, and operation. He completed his BS in civil engineering at the National Taiwan University in 1971, his MS in structural engineering at Rutgers University in 1974, a second MS in geotechnical engineering at the University of California, Berkeley, and also his PhD there, also in geotechnical engineering in 1977. After he returned to Taiwan, Dr. Cao served as an engineer for some very large projects there, including the Taipei Mass Rapid Transit Project, as well as some others. When the concept of high-speed rail emerged there in the late 1980s, he soon became involved. He first participated in the initial feasibility study and beginning in 1994, he served as the advisor to the provisional office of the project. After the project was privatized in 1997, he was named Vice President of Engineering for the Taiwan High-Speed Rail Corporation and served in that capacity for 11 years until his retirement. He then resumed his academic career in 2008, first teaching at National Taiwan University and later several others, including here at the University of Illinois at Urbana-Champaign in 2010. Over the years, he's developed and taught several classes, including high-speed rail engineering that he's teaching here this semester, also high-speed rail planning, high-speed rail construction management, high-speed rail operation and maintenance, and integration project management, all of these drawing upon his extensive experience with the Taiwan project. Dr. Gao also serves as the advisor to the World Bank on its high-speed rail projects in China, and in 2014, Dr. Gao was invited by the Hong Kong MTRC to serve as an independent expert for their Guangzhou, Shenzhen, Hong Kong Express Rail Link project. Dr. Gao has presented numerous invited lectures on high-speed rail to railways, government offices, and universities all over the world, and is a licensed professional engineer in California and Taiwan. Please join me in welcoming Dr. Gao as he presents the future of high-speed rail systems.
Thank you. Thank you, Chris. Thank you, Chris, for inviting me again. First thing I want to say is Happy New Year. Today is the Lunar New Year. It's a great way to celebrate the New Year with a Hay seminar. Great dedication. My first time giving a talk in the Hay seminar was in 2010. That year, America has a dream, the vision for high-speed rail for America, and that is to develop high-speed rail in several corridors in America. Today, I like to talk about a future of the high-speed rail, maybe including America. There are a lot of changes since the first time I talked here. And I like to cover all the changes and maybe look into the future, what would be like. But before I start, I like to go back the history a little bit to see what have we accomplished so far. And from here, put the anchor on our discussion, and then we can go forward. So in the last 54 years, I think, since it first operated, like Chris said, we have developed a high-speed rail, which is very reliable, very efficient. Okay, so many countries are developing it. When Taiwan first became a high-speed rail in a high-speed rail country in year 2008, Taiwan was number 7 in the world. Now there are 26 countries. Okay. The high-speed line we have now is 30,000 kilometers around the world. Every year, there are 1.6 billion people taking the high-speed line. And the high-speed rail has proved to be efficient more than other transportation tool for the travel distance about 2.5 hours. In other words, 80% of the people on the same corridor with the airline, people would prefer taking the high-speed rail instead of airline for the 2.5 hours. That is equivalent to about 500 kilometers. Okay, so 80% modal split. 26 countries are either building or are operating high-speed rail now around the world. So with this, I try to expand it on the subject. When I first come here, that time, international organization, UIC, which is actually a French word for Union of International Railroad, okay, make a prediction in year 2009, the high-speed rail would be built in this kind of the quantity in the future. What they base on are the project in construction, the project in consideration, and put all these numbers together. What I like to point to you on this graph is 1964. We have the first high-speed rail developed in Japan. Year of 2008, in 44 years, we built the first 10,000 kilometers. If you look at the 20,000 kilometers, that was year of 2012. So in 44 years, we built the first 10,000. In 4 years, we built the second 10,000. How about the third 10,000? It's 2015, 3 years. So that's how fast the high-speed line has been built. 2 major areas, China and Europe. Okay, and I will go back to this later on. But the UIC prediction in year of 2009 was not too much off, because today, you look at this chart, 2015, 30,000 high-speed rail will be built, and it was on. Okay. Another experience we learned is from this chart. This chart is a combination of all different high-speed lines. And looking at on the same corridor, what is the market split between airline and the high-speed line? Okay, so we have a conclusion from that. For travel time of 2.5 hours, high-speed line command 80% of the market share. Okay, So for 2.5 hours, high-speed line command 80% of the market. Okay, let me show you the study or the finding in the Japanese market. In the same corridor with airline, compare with car, high-speed line, and the airline. This is their conclusion on the market split. Let's look at 50% market split between car and high-speed line. It is somewhere around 200 kilometers. Okay, so we probably can say 200 kilometers is the indifference distance, or indifference hour, 2.5 hours. For this distance, people could ride the high-speed line. For the distance below this, people probably prefer to drive. Okay, we can look at this one. 50% market share between high-speed line and air. Again, probably that's a so-called indifference distance, indifference travel hour. So indifference travel hour between high-speed line and air is somewhere around 3 to 4 hours. The distance is between about 800 to 900. So there are this kind of market split likely to happen when you have a choice, car, high-speed line, or air. So that's the experience we learned. From this one, actually, we can conclude further than what I just said. People prefer to drive in this range because the car provides a door-to-door service. You come from your door to where you want to go. So the door-to-door is its advantage. But then, beyond this, driving becoming too much burden, tiring, boring, challenging. So people prefer not to drive. Same for this one. When high-speed line goes over 2.5 hours, because high-speed line is fast, but not as fast with air. So the total travel time for the air could become shorter than high-speed line after this distance. Okay, so from here, we see 3 types of the desire, people taking the high-speed, taking all these 3 modes of transportation. People take, in this region, people will drive because it's door-to-door. People in this region would take high-speed line because it's the center to center, city center to city center. People had to take this trip because it's airport to airport. Okay? People travel by center to center still have some last mile or the first mile to connect to become door-to-door. Okay, and that is their challenge. People from airport to airport still far away from where they want to go. Okay, so except for a very long distance, otherwise they won't do it. Okay, so this diagram explains very well the psychology of people taking different modes, or the reason, economic reason or time reason. Okay, so that is what we learned from past in a simple way. Now, I'd like to take you to look into the future. I will start with one thing. I will start with a study. Actually, it's not a study. It's a roundtable discussion in year of 2006 in the Congress of High-Speed Rail held by UIC. So it's a UIC Congress held in year of 2006, trying to look into what are going to happen in 2046. In other words, 40 years prediction for what are going to happen for the transportation field and mostly in high-speed rail field in 40 years' time. So that was their effort during that time, and that is our starting point. This, for your interest, these are the panel leading the discussion for the roundtable. Okay, now I want to show you what they're finding and what they think. And the first thing they think about it is, within these 40 years, we will go to the end of the oil, no more oil. And we will start using clean energy. Okay, and that was the time in year 2006. Mentality is a little bit different now, because in this between 2010, shale fracking become viable. Before that, it's still not viable. So they have probably haven't foreseen that one. Okay. Second one, new infrastructure will be built. Okay. Third, interoperability of the train. They consider the experience in Europe. The train become borderless, will become international. So within 40 years, train can go from country to country. Okay, borderless. 4, oil company, airline company become an operator of the high-speed line, not become competitor. They will join in. Maglev will become mature. In year 2006, they make this prediction. Remember, the Chinese Maglev start commercial run in year of 2004. So in 2 years after the Chinese Maglev start running, they say it will become major transportation tool. Okay. Consolidation of external effect into production cost. Many of the high-speed rail projects, the building cost or the construction cost was not considered as part of the return. Okay, but they think it should be. All the economic effect of a high-speed rail project should be also considered as part of the input, part of the what you can gain from. Okay, so you should try to consider this part. Okay, so the panel suggests that car will be banned from the center of the large city. Again, in year of 2006, and the guy proposed it probably from Singapore. Next one, new communication system will reduce mobility. That have been said for many years. But with what we have now, so easy to get on a mobile, so easy to talk to the people, we still do not see much of a reduction on mobility. I think hugging an iPhone is different from hugging a man or a person. Okay, so probably there's no replace for that. Widening of the standard gauge. This is a little bit futuristic, okay? But never say never, okay? Who knows? Okay, 10. Single European Railway Authority will be formed, okay? And this spell underneath after one concept, that the European railroad will become one network. So if it become one network, it's sort of reasonable to say it will become one authority. Okay, so this was what they say. I will look at the future. I will do my back shot. I will do my thinking and try to predict from what they think and what I see now to see what will be future like. Okay. I will look at from two directions. One is the new technology innovation. I think it will have a very big impact. The second one is a new paradigm we are living in. We used to live in an old paradigm, or the previous paradigm, which we think democracy, we think sustainable living, we think green mobility, we think clean air are what we're looking for and what we should be pursuing. That paradigm maybe is changing. And at least you are seeing changing. Is this changing going to last, affect in the future? Or is this changing is just a hiccup? So I will start this. Before I go into each innovation, technical innovation, I like to start with a short story. This short story had to do with all these phones. These are the public phones in the Taiwan high-speed rail station. When we did the design in year of 2000, we designed a lot of public phones in the station, because that's the way people communicate. Taiwan high-speed line opened in year of 2007. When we opened, nobody used this phone because everybody carry their own phone. Okay, so this phone was put there. After the operation, it's gone. So you don't see any public phone in the Taiwan high-speed rail station anymore. Okay. Same, the sign say the telephone is not installed on the train. So this telephone booth is still inside the train, but the phone never installed for 11 years. The sign is always there. Again, the train was designed in year of 2007. When operation time come, everybody carry their own phone. So what I like to say is within 7 years, the public phone become extinct. Nobody uses the public phone. Think about it. Not just the public phone, many things. Xerox become extinct. Kodak become extinct. They no more exist. Remember, Xerox was once a birth. When you talk to somebody, can you Xerox for me? Just like we say, let me Google it. Within 7 years or within a few years, they disappear. When I talk to my young secretary, I said, can you Xerox for me? She looked at me with a big eye. What are you saying? Okay. So technology will change us fast. So I like to list the technology I think which will impact us, change us. First of all, new high-speed rail system. Faster trains are being built. Maglev will come in. Vacuum train, Hyperloop. New car, driverless car, electrical car, car-to-car communication. New business model, Uber. Artificial intelligence with big data, deep learning, machine learning, and image recognition. New energy source. And the next generation of robotic drone distributed manufacturing. All this will come in our life. And they will impact our transportation society, and they will impact our life and impact high-speed rail. So let me look at the first one, the driverless. driverless car. I don't have to elaborate the progress of the high-speed, the driverless car. You all read, you all know, you all see, they are coming. Their progress is very quickly. Some of the car manufacturers even partially put it into daily use. Okay, put them into application now. Different type of the vehicle have been tried with driverless technology. This is the bus in Helsinki, driverless. Then you have a truck, which is driverless. So it's coming. Driverless car is coming. But my point is how it is going to affect our transportation, especially the high-speed rail transportation. So let me go back to the basic. The basic is these people, they don't want to drive beyond this because it's challenge, because it takes time, because it's boring to drive beyond 2.5 hours. So if you become driverless, you can do your singing and dancing in the car. You can foresee that this line is going to push in this way. Is that right? So the sweet spot which high-speed rail line has been occupying will be squeezed. So we can see that the squeezing from this line is coming. Okay, next one. Driverless Uber. If driverless car has been put into utilization, driverless Uber is coming too. It's just a marriage of the two innovations. So it's coming. Okay. What I'm interested in is how this is going to change the high-speed rail business. Let me show you this graph. There's a lot of meaning on it. High-speed rail transportation is quick, fast. But again, it's city center to city center, is what we said. That's its advantage. It still have a first mile to go with it and last mile. And they usually are time-consuming, inefficient, and slow in contrast to this. And the current time, the high-speed rail operator cannot do anything to this first mile and last mile to help the passengers. So it is left to the passengers to struggle through it to get to the station, or struggle through it to get out of the station, even it is in the city center. So now imagine if you have a driverless car, a driverless Uber, which will start from your home, taking you to the station seamlessly. So this first mile and last mile will become much easier. So will that also enhance the transportation of high-speed line becoming door-to-door? So this combination, if it's efficient, seamless, people start thinking it is door-to-door. Okay, so if that's the case, then this line may not move this way, this line may move this way. Okay, so there is a possibility. Innovation number 3, I want to talk about it within that long list, is Maglev. Again, 2006, the UIC panel predict that there will be complete success before 2046. The first high-speed line was built in China in 2004, and it's still in operation. For a while, it was quiet. But it is recent. Japan started the second high-speed line building. And this is the Chuo high-speed line, running at 550 kilometers per hour, will be connecting from Tokyo to Osaka. So this is the route line, starting from Tokyo to Nagoya and then further down to Osaka. From my understanding, my Japanese colleague maybe comment on this, the original concept is either building another Shinkansen, which is this way, or building a Maglev line. The current Shinkansen is too crowded and also a little bit old. Each day is taking 360,000 people, this line. 360,000 people per day is like taking the population of Champaign, Alabama, go to Milwaukee and come back every day 3 times. What I want to say is this is a very lucrative line. Okay? The construction cost of this line we covered in 7 years. After 7 years of 1964, that's 1971, the monies, the depreciation are all gone. It's all profit. Okay, so it's so crowded, they are building the next one. And the next one will be a new technology of Maglev, is the superconductive type Maglev. Okay. Let's see what it can do. It will cut the travel time Tokyo to Nagoya from the current Shinkansen line, which runs as 285 kilometers, from 90 minutes to 40 minutes. 90 minutes to 40 minutes, that's a lot. Almost cut 60% off. The travel time between Tokyo and Osaka, 150 minutes to 67 minutes, a little bit over an hour. That's revolutionary. And this is coming. I try to make a comparison for construction cost. A construction cost of this is $192 million per kilometer. 192. A conventional railroad now, a conventional high-speed railroad now is about 50. Okay, so 50 million compared to 192. So it's about 4 times, the 4 times difference. The justification of this cost is, with this line, the people living in Tokyo, Nagoya, and Osaka will be in one city because it's only 67 minutes from one end to the other. So there will be 64 million people live in one city. The important part is to predict annual economic benefit. It's 7.1 billion. Okay, investment of 90 billion will get 7.1 billion back per year. Okay, so this is what we said is right, or what people think. The external effect should be considered as part of the cost. You recover some cost already from the external benefit. Okay, so that is what? Not Japan is doing the second superconductive Maglev. China is doing its Maglev too, but it's the Siemens technology of the Maglev type of the operation. Okay, so this is China's idea. Okay, and they will expand from this to this. So what it tells us is Maglev is coming, okay, and will become part of the life in the future after Japan, after China. So again, go back to the basics. What does this going to change? The reason this line is here, because high-speed line travel at 250 to 300 kilometers per hour. Airline travel at 800 kilometers per hour. There is a speed advantage. So over some particular distance, people preferred to take the airline because it's time efficient, although it's not as comfortable. But now, is the high-speed line becoming 550 kilometers per hour? What is going to happen to this line? It's going to push out the picture. Airline will have no existence if there is available of Maglev. Okay, so we will see the change of this balance, the change of this indifference. At this point, I'd like to go back to the subject I just said. When year of 2010, when I come here, America has a dream. The dream is to build high-speed rail around the world. After that, I teach here. I also teach around the world. And when I talk to people, I'm teaching high-speed rail class in America. The first thing I hear is, are you? A little bit doubt. The second question follows, do they ever be able to build one? That's the second one. There are short answers to that, but today, because I have all the background I told you, we have a common understanding now. I want to use this one to explain to you why it's slow in America. Because on this one, America has built quite good highway actually. They are not as congested. They are not as challenged to drive. You can not do the total singing and dancing, but you can at least do the singing. Okay, so this line actually can, in the America, if it's America, it probably will move to 3 hours or 3 hours and a half. Okay? America also built a lot of the airport, small airport. Get you to almost to every town. Every small town has an airport. It's not efficient, but it's there. Okay? So getting to small town maybe is not difficult. So this line actually can go a little bit this way. So what we see in America, the sweet spot for conventional high-speed rail actually is not that big. Okay? These two lines probably is quite close. And people will try to use the short-haul airline and long drive to patch up the gap. And that is happening in the United States. Still doable. It's not ideal, but still doable. In other words, the high-speed line we have now is not sexy enough for Americans to excite it. So what will excite Americans? If Maglev comes into application, from here to New York, it's 1 hour. America will get excited. So I would say America may miss all these conventional railroad high-speed line and direct jump to Maglev in the future. Okay, if America still want to build high-speed. So that's why maybe it is coming slow. So this is my explanation. I don't have the chance like this to explain to common people. Okay, so you have the opportunity. We at least can understand this curve. If Maglev is become impossible, the next one, which may be a little bit futuristic, may be able to put on the drawing board again. That is vacuum tube. All the trains running, their limitation actually is air resistance they get. Air resistance increase with square of the meter, a square of the velocity. The power you need to push the train increase with cube of the velocity. So velocity and the air resistance is one of the things you have to try to conquer. Consequently, the idea goes to vacuum tube. Many studies already have been done. Two reasons to stop it. First of all, it had to be internal in order to be vacuumed. A high-speed line is very big. The tunnel is 90 meters square. Vacuum it is a challenge. Second, construction it is very challenging, very expensive. So what changed the equation? The change of equation are two. One is Maglev comes in. When Maglev comes in, the train do not have the catenary power, do not need the catenary line. The tunnel can be reduced to 9 square meters. 90 to 9 square, 90 to 9, 10%. Construction costs will be much reduced. Second, AI technology. People are already trying to build a tunnel with robot. So when robot is building the vacuum tube for us to run the vacuum train, then you see maybe there's a chance. Okay, so that is vacuum tube train is not something we can say it's not coming. If it is not impossible, then Hyperloop probably also have a chance after building tunnel becoming an easy task, an inexpensive task. Number 4, technology innovation which can affect us. AI, artificial intelligence. Artificial intelligence is coming. It's coming back in recent years with 4 major improvements in the system, which is data mining and big data, which is deep learning, which is machine learning, and which is image recognition. It's now doing quite well. And we'll see the full application of it is coming. This gentleman is in trouble because he will lose the game. This is in year of 2017 when the Google AlphaGo is playing with the best professional Go player in the world. In year 2004, they are equal, 50-50 winning. In year 2017, he lost by 0-7. AlphaGo beat him totally. After the game, he considered that human will never be able to beat AlphaGo anymore. And why is that? Let me give you a secret what the Google engineer was doing. What Google engineering was doing is using this technology of deep mining, deep learning, and machine learning, they put two AlphaGo to play with each other. The two AlphaGo can play 10,000 games a day. 10,000 games a day, and they remember all the experience. They learned all the experience of playing 10,000 games. For him, it will take 10 years to learn all the 10,000 games. Machine do it in 1 day. He did it in 10 years. And if he can remember all the games. So that's why he said there's no chance. Okay, so artificial intelligence is coming in and is changing our life. That's not my interest in playing the Go. I'm not a Go player. What I'm interested in is how it's going to change us in the transportation field. And this is what I think will change our transportation field. Now, what we have is your mobile phone. And you download a lot of apps. One app for Starbucks coffee, one app for pizza, one app for MTD, one app for airline, and so on and so forth. And you try to organize it. Okay? So this is now. What would be in the future artificial intelligence will do for you? It will do all the organization for you. He will present a solution to you. So that is what artificial intelligence is going to do for you. One solution, one customized solution for you. It will order the coffee you want to the airport or to the train station. It will have the Uber standing inside of your house before you leave. It will take you to the train station. It will bought a ticket already for you. You just walk in, seamless, sit on it. If the train is delayed, he will automatically update your travel plan. In the other end, the Uber will also know you are late. You have not to do anything. And then when you arrive, you want to transfer to airplane, the air ticket is being bought. And if there is any change, AI will do the work for you. So this is coming. Artificial intelligence is going to help us with our travel plan, change our travel mode. And that's what I want to say. Are you familiar with this? Hi, Siri. Later on, you can tell, hi, Siri, arrange my trip to Tokyo or to New York. And I want to have a coffee pickup. And the flavor you like in Starbucks, the size you want, will be as what you want. Prepare for you as Starbucks. So that will be the future. I'm not talking about actual two future. High-speed rail operator is already doing this. High-speed rail operator is trying to become the backbone of this. So they are making this type of the AI, trying to make it available. So they will organize for you this one-stop type of the travel plan with the high-speed line as the backbone. Okay, and so this is called Mobility OS. Siemens is doing that. Many other companies maybe is also doing. So that is what is going to change. And there are more I can say, talk, but I'm limiting my time. So I want to go to my second topic. It's the new paradigm. What is the new paradigm? Because we live in an old paradigm before, or a few years, or 1 year before. We think democracy. We think sustainable living. We think green mobility. We think clean energy is what we should be pursuing. So that was before. How about the new paradigm we are coming? Are they going to change our life? Are they going to change the development? Are they going to change the world order? So in 2006, what was looking for is we will run out of oil. But the shale fracking make a change. The available of the shale oil may be prolonged the supply of the oil. So maybe it's not that. We have been looking for clean energy, but is that concept still wrong? Following with that kind of clean energy, sustainable living, we go into this global warming. And that time, we also upheld as our principle, try to prevent climate change, prevent global warming. Remember, during those age, every word, if you put a green before it, then that's a fashion. Green building, green architect, green energy, green transportation, everything is green. Okay, just like nowadays, the buzzword is what? The buzzword is smart. Smart buildings, smart living, smart transportation, smart everything, smart husband. Okay, so we are in searching of green mobility during that age. So this is what 2006, the panel said. Are we still doing that? Comes with that idea is this idea called European Railroad Network. And the idea is that European country will join together with railroad. Okay? The red one are high-speed line. The yellow one is a little bit lower than high-speed line. And the train will become borderless. Train will become borderless to take people around, and that's why European community is borderless. Okay, so that was the idea then. So if the railroad become one, the network become one, the authority become one, reasonable. Okay, so that was the prediction of this old paradigm we were living. But now, with the terrorism and the refugee problem, we are seeing different pictures. Europe is in crossroad. We don't know what's the future of Europe. And if Europe become in trouble, disintegrated, it's not borderless. And high-speed line, if you had to get the immigration check, security check at the border, it's no high-speed line anymore. So not only Europe is in danger, European high-speed rail network may be in danger too, because there's no borderless. Not only Europe is in trouble, globalization is in trouble, democracy is in trouble, sustainable life living is in trouble. So is this going to be a trend, a new paradigm we are living, or is this only a hiccup? It affects us. It affects our future. With all this, actually, there are some areas which is developing quite well. And that is Mid-Asia and South Asia. Mid-Asia used to be blocked by the Iron Curtain. So the country was sort of plagued by isolation. Southeast Asia was plagued by war and poverty. But now with time gone, it's prosperous. Okay, so these two areas will be a huge area for development and prosperous. And that's what we can see. It is also helped by one program, which is called One Belt, One Road Initiative. Some of you may follow this, some of you probably it's too distant to follow it. This is an initiative proposed by China in the year of 2014. And its effort is trying to bridge the Mid-Asia with infrastructure from China. This infrastructure is road. I saw my friend from Mid-Asia is nodding head because he is familiar. Okay, so China is trying bridging the infrastructure gap so they can expand from China to Mid-Asia, and that helped the development there. China is also trying to bridge the infrastructure gap between China and Southeast Asia by railroad and high-speed rail. Okay, so this will be coming. So what we can see from the current new paradigm is that this area will become prosperous and will become a regional power. The new paradigm, what I am seeing is America will stay a power center in American continent. Asia probably will be dominated by the Chinese. Europe, I don't know, is at crossroad. So that probably is a new paradigm coming. China is not just put this as a slogan, the Belt and Road Initiative. No, China is backing up with the money. So they set up an Asia Infrastructure Investment Bank. This Asia Infrastructure Investment Bank, including most of the country, owns the so-called regional One Belt, One Road. 84 members, including England, Germany, Netherlands. Okay, they all try to put the money in to participate in the project which will be developed for the Mid-Asia and Southeast Asia. Okay, so the idea is there, the project is there, the money is there. So what I like to come to here is we should see that region becoming a future development after China has so much development. They will follow the example of China. My advice to the students who are from Asia, maybe you should go home. After you start your study, there's plenty opportunity, plenty challenge for you. My advice to American students, maybe home is warm, but away from home is challenging. So maybe you should go to Southeast Asia, Mid-Asia. Practice your learning, practice your technology. Okay, so that maybe is something you can consider. This is a opening, a groundbreaking for the China-Thailand high-speed rail. So this China-Thailand high-speed rail connect China to Thailand. Okay, so it's in construction. The Malaysia-Singapore high-speed line is also in construction. Okay, so this idea of Southeast Asia high-speed rail network actually is moving ahead. It's happening, okay, and will not stop. That's my take. So I do all this is because I want to share with you what I think would happen. Okay, and maybe you can have some use of it. I do not exhaust all the things I think, but major ones are here. Last 3 minutes, I'd like to share with you an idea, a very small idea we have. This very small idea is called UIC University Alliance Chapter. This is organized by UIC, again, International Railroad Association. UIC is a trade union which support all the railroad operator and the railroad equipment manufacturers. So they support all big companies. Actually all major railroad operator, Amtrak or all this company, they belong to this organization. Big manufacturer company, Siemens and so on and so forth, belong to this company too. Operator and the manufacturers, okay? And they are spearing ahead on railroad transportation study, high-speed rail transportation study. UIC has this new idea now. They would like to be the bridge to bridge the research capability of university with all these big players. Okay, so they like to form a chapter or a committee to bridge all this effort. So we have the first kick-off meeting for this committee. This is a professor from King's University, Imperial College, okay? This is Mr. Andrew Norton. He was the chief engineer of the UK second high-speed rail 2, HS2. Mr. Labov. Mr. Labov is the representative from UIC. I was honored to be the representative for Railtech and the National University of Taiwan. Okay, so this was our initial member, and we plan to have a meeting every year, 1 time or 2 times. Okay, so that was. What do? We would like to encourage research among all universities, and we will try to start kicking some idea around. And with the idea, if we kick around within the university and get support, and what we will do is, what UIC will do is, then he will persuade their member, those manufacturers, those suppliers, to pursue the idea. Okay, so one of the ideas is called virtual coupling. The virtual coupling is the idea you have a train which can almost run very, very close. Currently, we have a headway of 4 minutes. But if we can establish some kind of virtual coupling, the braking system in the previous train will be synchronized, the braking system in the second train. So they two are moving, accelerate or decelerate at the same time. So that gap can be reduced safely. Idea is not new. Idea is one of the ideas I talked to you. It's car-to-car communication. It's just making it train-to-train communication. Then you can reduce the headway. You can increase the capacity of the railroad. So that's one. The second two is the wireless train, which I talk about it. Try to get rid of the catenary wire. Try to reduce the dynamic envelope. Okay, And maybe one of these days, catenary wire pantograph is the password. Okay. So what I want to tell you about this is because since UIUC is one of the member, Realtek is one of the member, I like to have one day bring the panel here to share with you about their knowledge and to hold a meeting in UIUC one day. Okay, so I conclude my speech for today. Thank you very much. Any question I can answer?
But before we do start questions, members of my class, they're all here, I think, so we'll just maybe start a little late. Yeah, so do we have questions?
So you don't think that high-speed rail in the United States is going to be successful in the short term, maybe in the long term, but not in the short term?
Okay, my take is maybe it will still going on, but slowly. Okay, California apparently is one of example. Okay, it is going there. Texas Central is another high-speed rail which is going on. Which has some difficulty. I don't know it's totally already overcome or not. Okay, that one I think probably still will go on, but both will be slowly. Let me tell you a story. This story is between Andrew McNaughton, which I just said, he is the chief engineer with the HS2. Okay, he has a conversation with the chief engineer of China Railroad Department or something like that. Okay, so the Chinese chief engineer asked him, how long you will be able to build this high-speed line? You HS2, and this goes through the translation. The translator come back say 20 years. The chief engineer got mad. Your translation is wrong. It's 2 years, not 20 years. How can this kind of length take 20 years to build? I think democratic country probably all will do that. Okay, the system actually now is aging, dysfunctional, inefficient, and we have to admit that. Okay, so it will go slowly, but unless something which is becoming very exciting, and it will show up how much difference American from other country. At the present time, still doable with all your tool. You have two tools. One is car, one is airplane. They can somehow try to match it, but not quite. But can still doable. Yeah. Okay. Yes, Chris?
Well, I have a question from one of the online participants, and this individual says, since it took over 40 years for traditional high-speed rail to explode in development, do you expect the same to happen to Maglev? It's taken decades to get almost nowhere. Are we about to see an explosion of Maglev?
Yes, I think that would happen too. Okay, we take a long time to learn, 44 years to learn. Okay, 44 years when Taiwan became the number 7 high-speed rail country, was 44 years after that. Okay, and now exploded. Same thing. I think it's going to happen to Maglev. 14 years from China first opened its high-speed rail line. So 14 years passed by. Maybe it will be quicker. Japan come in the next, and then construction costs can be reduced. because of automation, okay, and then more people looking at bigger picture of the benefit, then it will accelerate.
Other questions?
Thank you for your speech, Professor Gao. Something that I was wondering about is, have you ever looked at you spoke in length about the major innovations on the left side of the graph about the cars and auto industry. Have you ever looked at the airline industry and how some of the major innovations in the airline industry could impact the high-speed rail in the future?
I think I have thought about this. Okay, and something is this the pre-check to get on board. Getting on board of the train, airplane, take about half an hour. Okay, and you including the security check and so on, it will take about a whole hour. A whole hour will get you from Tokyo to Osaka already. Okay, that should be changed, and this can be changed, I think. So we have a lot of people with this pre-check, and so maybe, so these are something which can change the equation. Okay, airplane supersonic maybe, but for sure the distance we talk about maybe supersonic, but it's not an idea. More energy efficient, save some money, but the money doesn't go to our pocket, go to the airline company. Okay, so yeah, there are some. I am not familiar with additional one. Mm-hmm.
Professor Gao, so the high-speed rail here, I think it's mainly refers to passenger rail,
Mm-hmm.
But for the Chinese One Belt One Road, is there any prospect for high-speed freight transportation as well? I mean, freight transportation.
Okay. There's another equation I haven't talked about here, is time value. The high-speed rail become profitable, and actually I keep on telling people, high-speed rail is only railroad which do not require government subsidy. Okay, because the high speed buy time, and the time value is high for people. Okay, so it become possible, become financeable, become viable economically. But most of the goods we are looking at, their time value are not that high. The television said 1 week late is okay. Okay, it doesn't have to be delivered the same day. Okay, so it's the time value. So far, most of the goods we are looking at, time value is not there. Okay, so like many people say, would Taiwan high-speed rail also run freight train? We say no. We make much more money out of people than goods. Okay, so why do it? And we don't have enough capacity for people anyway. Okay, so most of the high-speed lines are not used for this purpose. Okay. But the railroad I'm talking about, expanding from west of the China out into mid-Asia, and now it's already arrived at Europe. So the freight is going land line to Asia now. It's transport on land instead of going through Suez Canal to Europe, and that is happening. Yeah. Microphone.
Hi, I have two questions or points, but I will add something to his previous question as far as the freight and high speed. We did see with SNCF when they built the TGVs, originally they built some post trains for the mails, but they've retired those now partly because the technology has changed where people email and we're not mailing paper letters and packages as much. if we are, they do not need the high-speed rail from Paris to Marseille or something like they used to back in the 80s and 90s when the system was developed.
Yeah, thank you.
So there again, technology might change the demands of freight. We might get more packaging from Amazon, but are people willing to pay so much extra for the same day or next day? Sometimes they will, a lot of times
Yes.
they won't.
Yes.
Okay. First question though is, you're talking about including the construction costs as part of the operations revenues to pay back for rail. But we don't do that for highways or for airports. So how, I would only agree if we can get airports and highways to recover their costs through tolls or fares to include from the operating revenues that these things have to be paid back, and they don't. So can we get society and politicians to agree that if we do it for rails, then all the modes have to be done the same, or are we going to have this mismatch where rail is going to be treated differently still like it always has been?
Okay, thank you. For your first question, actually, I also like to amend. Federal Express used to have a high-speed train in Europe. Okay, but now I don't know whether it's still there or not. Federal Express, it's like a TGV has a freight train, but then it's not there. Okay. Your second question is external cost, external benefit. Can you consider the external benefit in the construction? Some government does. America may not, but some government does. Japan do, Taiwan do, England do. Okay, Department for Transportation in England has a menu. What you can calculate. You cannot throw everything in. Okay, so they have a guideline what you can throw in. Okay, so maybe it's time for America to change that.
And the other point I wanted to make was about Europe. What I think in the end we will end up with this European Rail Authority, because I've already seen it starting. I'm living in France now, and I live in Lille, and there is the ERA office is actually there. Surprised me. But one of the reasons I chose Lille is because of the transport, that I have a choice of Eurostars or Thalys or French TGVs. Right now they are separate companies, but there's also a website where you can find all the connections with one website. But SNCF has been decentralizing and creating new subsidiaries, and we now have the WE TGV that serves from Tourcoing down to Paris, but I have to go to a separate website. It's owned by SNCF, it's the same TGVs, it's the duplexes even, but they've been repainted, and they end up on the same high-speed line, but they're 10-euro fares, which is amazing. But we're seeing, right now, I'm seeing a fragmentation of marketing, and some of this has been privatizations in the UK with 6 different railroad companies and all this, and it's being harder right now artificially, whereas before you could go to SNCF and find every single train to everywhere in France, and now I'm having to look up 2 or 3 websites. So how are we going to get back to getting a European-wide one booking site when we're seeing artificial marketing with brand names and color schemes and separate websites? So that's what's aggravating me, because it's now wasting my time. How do we get back to where it used to be with one company?
Okay, you are talking about liberalization compared to centralization. And that period was during the European railroad liberalization. So there is a period of time, like in England, everything is privatized, liberalized. You compete, free market competition. And now, of course, we also see people, or people experience the difficulty. Okay, are we in the time of sweeping back, or maybe it's something you cannot go back? Once you liberalize, it's like a monster unchained. Yeah, and American Airlines probably something like that. We see the service of American Airlines keep on decreasing, and they manipulate the price. Before it used to be 2 class, now it's 9 class. Yeah, so I don't know, I'm not a market specialist, but I see the trend. The trend is because of liberalization, free enterprise, competition. And this trend probably it's going to stay that way for a while because the current thinking is you can do everything you want.
I think we're going to have to wrap it up.
Okay.
But I would say if people have some additional questions, well, I guess there's another meeting coming right after this. But I would say to our online audience, there's several questions that they have posted. If those of you posting questions online, if you want to send them to us via email, we will forward them, including your email address, and we'll forward them to Professor Gao. So with that, I'd like to thank you again for your presentation.
Thank you.